In this video, we're going to look at the mathematical set operations, and as you're about to see, Python provides these both as operators that you can apply between two sets, as well as methods that you can call on a set object. And there is a slight difference between the two different cases, so I'll point that out as we go along here as well. So let's start by pasting in a snippet that is implementing a set union operation. In a union operation, which I'll execute here, what you get is a new set in which you have all of the unique elements from the set in the left operand and the set on the right operand. So you'll notice if you look at those two sets, there was one duplicate value, 3, between the two different sets, and therefore in the new set I have 5 total elements rather than 6. Now we can implement that same type of operation with a union method call on a set object. So here we're using a set literal on the left side of the dot, but we could also have a variable, for example, that refers to a set. We could also have the result of a call to the set function on the left side of that dot. All three of those would represent a set object on which you can call the union method. Now, what makes the methods interesting is that they're a little bit more flexible. Yes, I can provide an argument to this method which is itself a set, but I can also provide any sequence of elements as an argument, and the union method will first convert that sequence of elements into a set and then perform the union operation. So if you look carefully at what we have here, the new set that we create is going to have 1, 3, and 5 in it, and then when it creates a set out of this list of elements, we have a couple of duplicates in here, so this list is going to actually be turned into the set containing 20, 3, and 40. The 3, of course, is a duplicate, so we expect to get a set now that has 1, 3, 5, 20, and 40 as its contents, and I don't know what order those will be, but it just happened to be the order that I specified in that particular case. So now you've seen the two different ways to perform a union with an operator and with a method. Now for each of the other mathematical set operations, we have similar scenarios. So the next thing I want to demonstrate is a set intersection operation, which we do with the ampersand operator. And what this is going to do is give me a new set of elements that contains the common elements between these two sets, the intersection of elements between these two sets. So if you look carefully at the two sets on the left and the right, the only element they had in common was the value 3, so the result in this case is a 1-element set. And of course we have an intersection method that we can use as well. So again, only the elements that they have in common are going to be the intersection of the set on the left and this list of elements that will be translated into a set in the argument to the intersection method. So in this case, we can see that on the left side we had 1, 3, and 5. Over here on the right we have 1 and 3 but no 5. So the intersection between these two is the 1 and the 3. You also have the ability to determine the difference between two sets, and that's going to be a new set containing the elements from the left operand that are not in the right operand. So for example, if we go ahead and demonstrate the difference operation, which is done with a minus sign. In the left operand we have 1, 3, and 5. In the right operand we have 2, 3, and 4. So the items that are in the left operand that are not in the right are the 1 and the 5. We have one duplicate value of 3 between those, so indeed we get the 1 and the 5 as the result. And once again, as you now expect, there is also a difference method that will perform the same operation, but its argument, in this case a list, is first going to be translated into a set before performing the operation, and in this case the difference is 1, 5, and 7 because 3 is a duplicate with the argument on the right hand side. Now we also have a symmetric difference operation, which is going to create a new set with all of the elements from both sets that are not in common with one another. So the elements in the left-hand operand that are not in the right-hand operand, and the elements in the right-hand operand that are not in the left-hand operand. So let's do a symmetric difference, which is performed with the caret operator. And in this case, you can see we get 1, 2, 4, and 5. In the left-hand operand, 1 and 5 are not in common with the right, and in the right-hand operand, 2 and 4 are not in common with the left. The one common value was 3, which is not included in the result. And just to show it, here is the symmetric difference method, which is going to perform the same task, but first, if necessary, it will convert its argument into a set, then perform the operation. Now there is one other mathematical operation between sets that you can perform, which is the is disjoint method, and its purpose is to determine whether two sets are disjoint, which is going to be a true or false result, and they're disjoint if they have no elements in common with one another. So as an example of that, let me go ahead and paste in a snippet here. In this case, we have 1, 3, 5 in the left and 2, 4, 6 in the right. There are no common elements between these two sets. So if I execute that, you can see we get a true result in that case. And just to show you a false result, in this example, we have 1, 3, 5 on the left, and we have 4, 6, and a common element on the right. So these are not disjoint because there is some commonality between them. So if I execute that, I get false.